We successfully displayed the names and the ages of the animals. But if you look at this array, there are other ways to declare. We can create a type aliases. If you look at struct animal, it is a bit long as type name. So we can define a type aliases for the struct animal, so it will be easier to type. For that, we use the keyword typedef. This is a keyword that allows us to define variable aliases for variables, aliases for data types. So struct, we're going to create an aliases for the struct animal, and then it will be animal type, which means that whenever you specify animal type as the type of a variable, it refers to struct animal. So we can replace this declaration with animal type. It is much more understandable because we can say we have an array of two animal types. Let's compile this code and see. Yes, it gives us the same result. Great. Another example would be to have a program that displays the account balance for a banking system. Going to delete all these things. A balance has a total amount and an available amount. For that, we can declare a struct of name balance. We have the total amount, and we also have the available amount. We can even define a type for this balance by using the typedef keyword to create type aliases. Struct balance, and the name of the alias for struct balance type will be balance type. Next, we can declare two balance, a balance for one customer and a balance for the second customer. Balance type customer one balance, and balance type for customer two balance. The next step is to initialize the fields or the member of the structure. Customer one balance, the total amount is 500 and the available amount is 300. For the customer two balance, total amount is 300 or 250. Customer two balance, available amount 250. Great. So as you see that we can create a structure, and inside the structure we have members, and each member represent a data items and can be of these data items can be of different types. In order to short shorten it, to make the name a bit shorter, we don't always want to type struct and the name of the struct. We can just create an aliases for the name of the struct and use that to declare different variables since it is a bit more easy. We can initialize a struct when declaring it, or we can initialize it after declaration using the dot after the name of the variable. For example, here, when you want to initialize this struct at declaration, you can simply put a curly brace, then put numbers like that. Total is equal to 500 and available is equal to 300. There is another way of initializing the struct. For example, when you are using this dot, then the name of the member in the struct, the order is not important. The compiler will understand which members you want to initialize in the struct. But when you're initializing the struct without the names of the members, you have to make sure you're following the same order as the way the members are declared. For example, for the customer to balance, we have 250. That will be for the total because the first member coming is the total. And the second one is 100. That means the available amount will be 100. You have to follow the same order as the way the members are declared when you are not using the member's name as in here, the first line. Great. What if you want to dynamically create a structure and have the access to that dynamically created structure using a pointer? This is also possible. I'm just going to include the standard library for this. Then we can access the memory allocation functions. Let's say we have a pointer of type balance, my balance, and to this pointer we're going to allocate a memory location of size struct of size balance type. So that means this function will allocate a memory space for our to store a balance. Then we'll return the address. The address will be stored in this pointer variable. Since it is an address, we have to use dereferencing to access the members in the struct. For that, you can do a parenthesis, then a start sign, my balance, then dot total amount. Again, you have to use the start, my balance, to do dereferencing, then available amount, then 150. You can use the dereferencing operator, or you can also use the arrow operator. When you are dealing with pointers, it is much easier to use the arrow operator to access different members. For that, you can say balance, then the arrow operator, the member name, And here my balance, the arrow operator, available amount 150. So this one here is equivalent to this one. It is much more easier to use the arrow operator when you are dealing with pointers. So a pointer on a structure, you want to access the members, you use the arrow operator because it is very easy instead of using the dereferencing operator like that, the star sign, the parentheses, then a dot. Not very convenient. And after the program is finished, terminated, we free up the space. But before, let's display the total amount and the available amount. That will be my balance, the arrow operator to access the member, and my balance, available amounts. Let's compile this code and see what we get. GCC main.c, the O option main. And here we have total amount and the available amount. So this is all for structure. A structure can also have pointer inside, and a structure refer refer to uh, we can have a structure that refer to another structure of maybe the same kind or different kind. The notion, the knowing about structure is important in a sense that when you are dealing with um, data structures like the linked list, the heaps, the stacks, knowing about structure will come very handy. I hope you understand or something in this presentation. Thank you for your time. Have a great day.